Another thing we can start measuring is area and volumes. Now, area and volumes will have some different ways of manifesting themselves, but I'll start with the idea of area. Initially, mathematically came from plowing, and as Babylonians would plow, they knew that they could get so much crop per row. And all the rows were the same width, and so they would go, 4, 1, 2, 3, 4 times 5, because there are 5 rows, and there are 20 crops you could get in there. Now this got extended, and what the Greeks did was they put a grid of equal-sized squares, where they measured divisions in it, and so each of these were squares of the same length. And so area became the idea of how many squares you could fill in. And so if I'm measuring across, let's say, in inches, there's 1, 2, 3, 4 inches, and then 1, 2, 3, 4 inches this way. So I have 4 inches times 4 inches. And so I get 4 times 4 is 16. But inches times inches, mathematically, that is inches squared. And so we say square inch or inches squared. Well, conceptually, we think of that as the amount of stuff we would need to paint the surface. But notice how it includes the square here. And I am squaring what inches are. So if I need to convert from, let's say, square feet to square inches, I need to, well, let's see, 1 foot equals 12 inches. So let's say I have 3 square feet. And I want that in square inches. So I've got to convert. So I'll go use my conversion factor. I'll divide everything by 1 foot, and I have 12 inches over 1 foot. But it's not squared. So I have to square the whole thing. And when I do that, I get 3 feet squared times 12 squared, which is 144 inches squared, over feet squared. The feet squared cancel, and I get, let's see, 2 carry my 1, 3 carry my 1, 432 inches squared. And so we can do our conversion factors in area, using the concept that area is the multiplication of one dimension times another, which means that the unit will be squared. And so that's why we see these areas getting called square feet, we see square conversion factors. Now what's nice is some conversion factors are done for you. So 1 square foot is 144 square inches, 1 square yard is 9 square feet, right? We can look some of these up. And so for anything rectangular, we multiply the length times width to get the area. Now in the geometry section, we'll look at some more equations from area. One of the things the book's going to look into at this point then is population density, or how many people per square mile. And so what we're doing is inventing a new unit. So once we have, right, and notice how the population density, and a density is the number of stuff in an area or a volume. And so population is people per square mile. And these are units. So the definition of the word tells me what I need to do. I need to take the number of people and divide it by the square miles they're in. So, for example, the example in the book says Wyoming has 568,158 people. There's 5,668, 158 people in Wyoming. And then there's 9,714 square miles to the state of Wyoming. So what we can do is we can find the population density. So I use the units and I divide these. And on the calculator, that gives me 5.8 people per mile squared. And that's the population density. Notice the units build the equation. That's a big thing that starts coming out with dimensional analysis, is that you don't need to memorize formulas for everything. Sometimes the units will tell you what to do. And again, for people going into nursing or dosage calculation, this will become really important when you talk about your drug rates. You'll need so many milliliters per milliliter or milligrams of drug per milliliter of fluid. Gives you a density of the drug within the fluid. You can also have the amount of grams that you need to process in the body in a given amount of time, right? The things per, something per, is a division. And so when you have one unit per something else, it creates the division for you. And this will be a powerful tool that we'll start exploiting more as we go. The equivalent to area is something called volume. Now we tend to think of volume in things like gallons, but I'm going to start volume by looking at cubes. And if I were to measure equal amounts on each side, I would make little cubes. Inside of this, little cubes, and I could stack all the cubes up like building bricks. And so just like I did with area, if I measure off in one unit, measure off in another unit. And so to kind of fill this, what I need to do to define a volume is I need to multiply the length times the width times the height. Right? Area was the length times the width, because that's all I had on something flat. When I give it a height, I multiply that. And so if these were inches, I would have a 1 inch by 1 inch by 1 inch, or I would have inches cubed. That's why we call to the third power cubed, because it makes cubes. Or multiplying something 3 times gives cubes. And so we do the same process with conversion factors in volume. And so if I have 1 foot equals 12 inches, then in 1 foot cubed, I cube this entire side, I have to cube this side. And so that's going to be 12 times 12 times 12 inches cubed. Or 1 foot is 1,728. And I guess you'll sometimes hear people say cubic inches and cubic feet as a way of describing these. And so we can count up the number of cubes and figure out their volume. But there's a really neat other system we use for volume, and that's not just the inches cubed or the inches cubed. We use cups. 1 cup, which is equal to 8 ounces. And let's see. We have 4 quarts in 1 gallon. And 1 gallon is 128 ounces. And I'm kind of looking at things as I go down a grocery store. And so we have the ability to convert in this English system of measure. And what's funny is these are fluid ounces. There was a different one for dry ounces. And so this system's fairly confusing. And we don't tend to talk about it a lot in science. But we can do conversions because these are equality signs, and we can use this to link cups to gallons, gallons to quarts, right? And there's pints underneath all of this. We have multiple ways of converting within the English system. I think what's more important is the metric system, which uses a liter. So 1 liter, I'll give the linking, is 1.06 quarts. That'll be our linking unit. Approximately, it's close to that. And then we can go down. We have centiliter, which is 10 to the negative 2 liters. We have milliliter, which is 10 to the negative 3 liters. And then there's also a deciliter, which is 10 to the negative 1 liter. And we can also go up with a deciliter and a hectoliter and a kiloliter. But what's neat about this system is there was a link. A cubic centimeter is equal to 1 milliliter. And this is neat because you'll sometimes see cubic centimeter as cc. So you ever hear in medical terms, 10 cc's, that's 10 milliliters. And this was done on purpose when they invented the metric system. When they decided to invent the liter of volume, they took a cubic centimeter and they linked it to a liter of water so that the system would be consistent, so it would be easy to convert, because the only thing you need for your conversions are powers. And so what we can say is, an aquarium, I'll use the aquarium example, has 36,000 cubic centimeters of water. Now this is easy to measure. I can take my aquarium tank and I can find its volume as length times width times height. And when I do that, I find that it's 36,000 centimeters cubed. Cubic centimeters. And so, but now I need to convert that into liters. So I'm going to take my 36,000 centimeters cubed and I'm going to look for my conversion factor. Well, my conversion factor is 1 centimeter cubed is a milliliter. So 1 centimeter cubed equals 1 milliliter. So I'll turn this into my conversion fraction. I'll put my milliliter upstairs and 1 centimeter cubed downstairs. And so now I've switched from the length measurement to the volume measurement. And then in 1 milliliter is 10 to the negative 3 meters. And so if 10 to the negative 3, so 1, 2, 3, I get 36 liters. And this is why we like using the metric system in science. It was a very quick conversion from measuring something in space to measuring it in volume. In the English system, I would have gotten something in square inches. I would have had to then take the square inches and convert that to gallons using a really complicated formula, which is, what was my, got it back here somewhere. 1 cubic foot is about 7.48 gallons. And so this is why you see the metric system being used in medical and science fields.